Hello there, this is Craig Hane or Dr. Dell, and this is going to be a series of videos on the subject of calculus. Now, this is aimed at anybody who is interested in teaching high school level mathematics. So this is aimed at high school teachers in particular, and it is also aimed at any of the students who have been through my first four tiers of our mathematics training. The first two tiers are the foundation course. And then the next two tiers are pre-calculus mathematics, which is the algebra, geometry, and trig that we teach out of the George Simmons book as a primary reference. And if you know all of the material in George Simmons' book, or even close to all of it, you're certainly ready to learn about calculus. And that's what we then cover in Tier 5. And I want to just tell you a little bit about what calculus is. First of all, there are two types of calculus. There's what's called differential calculus, and it involves a function called a derivative or an operation called a derivative. And then there's integral calculus, and it involves an operation called integral. Now, these are two quite different concepts. Derivatives involve rates of change, and integrals involve the summation of infinite sums, or it's the accumulation of things like area or volume. Now, calculus, as we know it today and use it, was essentially developed in the 1600s by a large group of people, but the names that are most associated with it are Newton and Leibniz. Newton was an Englishman, Isaac Newton. Gottfried Leibniz was a German, and they were contemporaries, and they both were credited with inventing the basic concepts of calculus, that we're going to talk about in a minute, and certainly discovering the most important aspect of it. And then the great mathematician of the 1700s, Euler, actually extended a lot of their ideas and really kind of developed the subject as it's known today. Now, the thing about calculus is it's critical to understand is to understand what is called the fundamental theorem of calculus. This was something that was invented or discovered by these guys and some of their contemporaries, although Newton and Leibniz are given credit for it. And it relates the concepts that seemingly are unrelated of rate of change or derivative and accumulation or infinite summation of integral, and it relates them. And it does it in a way that makes solving certain calculus problems very, very easy to do uh, compared to what you would do if you couldn't do it. Now, you might say, well, of what importance is calculus? How important is it? Well, the answer to that is basically it is responsible for modern technology as we know it. Modern technology and engineering and science all moved forward because of this tool of calculus, this powerful tool. The very first major scientific work on this, and some people consider it the greatest of all time, was Isaac Newton's book called Principia Mathematica. And this was the first treatment of Newton's approach to physics. And it became then the basis of much of the modern technology we have. He applied it particularly to astronomy, but he also applied it to several other branches of science at that time too. So what I'm going to do in these videos is explain to you, first of all, in the first video, the concepts of derivative and what's involved in that. And then in the second video, we're going to talk about integrals and integral calculus, and then most important of all, how the fundamental theorem of calculus is used to provide us a powerful, powerful machine for calculating integrals when we need to do so in science. Now, I will tell you, I think the first video that I've done is about 22 minutes long, as I recall, and this is about 29 minutes. I've also, I'm doing this introduction video after I did these first two because I didn't know how long they would last. And I originally thought about making one video, but I decided to break them into two. And as I reviewed those, I have discovered 3 or 4 what I consider to be trivial, careless mistakes, and I hope that you'll be alert enough to catch them too. Uh, this is what I call kitchen table math. This is how I often teach students, particularly if I tutor them with Skype. and it's also how I've created a whole bunch of videos that we use in our online training programs. I think of this as my kitchen table, and you are sitting there with me, and I'm simply talking to you about it. Now, when we have Skype tutorials, of course, then you can ask questions and it can be interactive, and that's nice. But when I'm just speaking to a larger audience, then pretty much I have to just pretend you're there and go along in that fashion, and that's what I do. So I'm going to invite you to watch these two videos, and when you get done and when you get finished with them, and when you feel you understand the fundamental theorem of calculus and the profound implications it's had for our modern technologies and thus our civilization, you're going to know something that very few people know. There are an awful lot of people that go to college and take mathematics and still don't really understand what this is. One of the problems is if you take a typical calculus course, you can get completely buried and snowed under with all kinds of details. And so this is designed to give you the overview before you launch into the actual subject itself. It's sort of the satellite view, if you will. It's the long range view. Now, in Tier 5, we're going to go into this in some detail. It takes most students about 3 or 4 months to go through Tier 5, which is calculus. It doesn't take very long with the modern tools to learn calculus. And of course, we apply the power tools that I'll explain to you in these videos to do that. A subsequent subject is called differential equations, and that's an extension of calculus. And that's also extremely important in engineering and science, and that's what we cover in Tier 6. But the basic concepts that are utilized in differential equations really all go back to the fundamental theorem of calculus, and that's what I want you to learn about in a heuristic way, kind of an overview way in these videos. So I hope you enjoy them, and perhaps I will see you then on some of our future videos. This is Dr. Dell. Bye-bye.